Yes, good morning class. Today topic problem solving of exercise 5.5, and this exercise very important exercise, because in this exercise 4 marks question come in the board exam every year without any gap. Then you do practice in this exercise with example also. This exercise very important exercise. In this exercise different tricks of this solving of the questions. Then use these tricks, don't mistake of the using of the identity. Now question here, differentiate of this y equal to cos x dot cos 2x dot cos 3x. This is a dot product here. Here three functions cos s, cos 2x and cos 3x. This is not simple question. Then in this type question, suppose a single question, then the simple solution here. But here 2, 3, 4 function here, then you can always use your log. Otherwise, you will do mistake in this question. So now, which identity will you use here? You have the identity here log m and l. M and any others, then you can write here log m plus log n plus log l. In this identity you can use here. So now taking log both sides, log y equal log cos x dot cos 2x dot cos 3x. Then you write here log m, and using this idea log cos x plus log cos 2x plus log cos 3x, and here log y. After that you will be differentiate here. Differentiate with respect to x. Then you will here differentiate of this here 1 upon y. Log y differentiate here first we write here dy over dx log y equal d over dx log cos x plus log cos 2x plus log cos 3x. Then differentiate here. Differentiation d over dx log x. This is the 1 upon x. But here differentiate d over dx log y 1 upon y. Then you again using the chain rule here. Then again using the chain rule here, log y 1 upon y, and then dy over dx. Dy over dx. First, this is the only here differentiation of the x with respect of the x, the simple log 1 upon x. But here differentiation of the y with respect of the x, then using that 1 upon y, and again using of the dy over dx. Then 1 upon y dy over dx. This is again using your log 1 upon cos x and d over dx cos x. Again this plus same here 1 upon cos 2x plus d your 1 upon cos 3x cos 3x. Then you can solve here again differentiate cos x. The cos x is minus sin x. This is a simple cos x and this is the cos x. Plus similarly again cos 2x here, so minus sin 2x upon cos 2x, and again 2x here, then 2 plus here cos 3x, so minus sin 3x upon cos 3x, and again you will do here 3x, then 3. Now look here, cos x here only simple cos x, then cos x to minus sin x. Here cos 2x to sin 2x minus sin 2x. Again you will do here the 2x. The 2x means only 2. And similarly here 3x means 3. Then you, and this is the dy over dx, and multiply by y here. Putting the value of y. What value of the y here? This is the putting value of y. Cos x, cos 2x, cos 3x, and minus tan x minus 2 tan 2x minus 3x. You can take this is your answer. Otherwise you take the minus common here, minus cos x, cos 2x, cos 3x. Here tan x plus tan 2 tan 2x plus 3 tan 3x. This is your answer. Both steps your answer. This is not matter. In this way I am taking only the minus sign here, and here this minus sign taking common here. Then your final answer. So very simple thing. Suppose you are taking the log, then solving process. Very simple here. Otherwise you will do the mistake here. If you do the differential without log. So don't differentiate without log. In this type question, every question you take the log and solve it. Yes, note down. Yes, students. Next question I am taking here. Question number 2. When you looking the question here, this is the looking very difficult. But this question is not difficult. This question is very simple question. But you will take here log here. Then this question is simple. Otherwise, this will be difficult. First, I will take here first log m upon n. In this way, means log m minus log n. We take this identity and solve it. Now, taking log. Both sides. Log y equal log x minus 1 x minus 2 upon x minus 3 x minus 4 or x minus 5, and this value of the root right here in the form of the 1 by 2. Then using the idea of this also, log n to n power n, then log n. First using this identity, then using this identity. So then first 1 by 2 taking this here, log x minus 1 x minus 2 upon x minus 3 x minus 4 x minus 5. Again 1 by 2 here, log m upon n. Using this identity here, m upon n, the log x minus 1, and using plus also here, plus log x minus 2. In this here plus into dot sign here, minus log x minus 3 minus log x minus 4 minus log x minus 5, and this will be closed. This is the numerator part, then writing a plus, and this part here using this identity, this is a minus form, so minus x minus 3 x minus 4 x minus 5. Very simple thing here. Next step, differentiate here. This is the log y. Again differentiate with respect to x. This is the, you are using the log identity, then using the identity of the differences. So then log x d over dx, log x, simple, 1 upon x. Then using this into 1 upon y and dy over dx, because here differentiating with respect of the x, the dy log y means 1 upon y, again differentiate of the y, dy over dx. Now 1 by 2, this log x means 1 upon x minus 1, differentiate again this to 1 minus 0, plus log 1 upon x minus 2, again difference this to 1 minus 0, log x minus 2, the 1 upon x, this is the using the identity log, and again differentiate of x minus 2, the differentiate of x is 1 and differentiate of minus 2 is 0, minus 1 upon x minus 3 are same, and again difference 1 minus 0, minus 1 upon x minus 4 or 1 minus 0, minus 1 upon x minus 5 same here, and 1 minus 0. Same way, same process here. So then 1 upon 2, and this is the only multiply 1, this is the, this second term is 0, first term is 1, then multiply 1 time here, so 1 upon x minus 1 plus x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5, x minus 1, x minus 2, x minus 3, x minus 4, x minus 5. Then multiplier and this y, dy over dx equal to y, then multiplying here dy over dx equal y upon 2. What value of the y here? This is the value of the y. I will write here value of the y here, root x minus 1, x minus 2 upon x minus 3, x minus 4, x minus 5. This is the value of the y. Then, and 2 also here. So 2 also means, then I will write here 1 by 2 also here. Then here write 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3, 1 upon x minus 4 and minus 1 upon x minus 5. This is your answer. This is your answer. Don't take your LCM. This is not required here. Without not cancellation here, don't take your LCM. Suppose here outside any terms here cancel this inside, then you take LCM. Otherwise, don't take LCM. So this is your very simple question. If you take the log, otherwise problem will be not solved. If you not take the log. Yes, note down. Next question. Yes, students, next question I am taking question number 4th of same exercise. In this question have this different types of the tricks of solving. Here y equal to x exponent x minus 2 exponent sin x. In this question, a special type question, first we will take the log error. So now, how to solve here? Look here. First, I am putting let y equal u minus b. This is this value of the converting u and this value converting the differentiate of this, the dy over dx equal du over dx minus dv over dx. This equation is first. Every question you make in this form first. Any question, suppose special type question, you will solve in this way. Now means value of the y. Now what value of the u here? U here x exponent x and value of the b here 2 exponent sin x. This is the value of the u and this is the value of the v. Then first I am taking log. Taking log both sides. First using this here. Now only this term I am using. This will be stop here. First I am using this term. So log u equal log x exponent x. One by one. I will solve the one by one. First solving this step. After then solving this step. One by one. First this is taking the log here. Then differentiate with respect of x. This is here 1 upon u and du over dx. Here first taking the property of here du over dx and here using x log x. First using the ND here log m into log m power n. Then using n log m. First using this ND here. After that using the product rule. What is the product rule here? Suppose product rule PQ here product. Suppose to value here differentiation of PQ here in product form. The first function differentiation of second minus plus second function differentiation of the first function. In this way, first function differentiation of the second function plus second function differentiation of the first function. In this identity using this is the product identity here. This first function here x, second function here log x. So now using here first function here x, second differentiation of the second function 1 upon x plus log x and differentiation of the first function is 1. The du over dx 1 upon u. The du over dx equal multiply this u here x cancel 1 plus log x. What value of the u here? This is the value of the u. Putting here x exponent x 1 plus log x. This is the value of the du over dx. Now putting this value of equation second. First here and this value first solve this second part here, then putting the values equation second and next equation third in equation first, then your final answer. Yes, next. Now v equal this is the second part here 2 sin x. Similarly taking log here log v equal log 2 sin x. This is the specific identity here. Same identity here. Then using sin x log 2. This is your log b. Differentiate here with respect to x. Here using the log identity here. Log m power n. Then this sin x will become here. The same identity here. This identity using also here. And this is a sin x log 2. Or this term here constant term. This is your constant term. Only differentiate of the sin x log 2 here constant term. Differentiate only sin x. And here log 2. Differentiate with respect to x. So 1 upon b dv over dx equal, what is the differentiate of the sin x cos x? Or log 2 here same. This is the constant value. The dv over dx equal b log 2 cos x, or what value of this? This value of this 2 sin x log 2 cos x. This is the value of dv over dx. Equation of your third. First equation, second equation and third equation. So now du over dx and dv over dx. These two values I will put here equation first. So now putting the value of du over dx and dv over dx in equation first. The dy over dx equal du over dx के x exponent x 1 plus log x, this is the minus sign here, minus, and value of the is 2 sin x log 2 cos x. This is your final answer. This is your final. But you will solve step by step. First solve this step, after that solve this step. Don't solve together. Don't solve here one together. Solve one by one. Then you put in the value here. Then you get the correct answer. If you solve the one times, then your answer will become wrong. You check this. Suppose you solve in the one time this questions, then this answer will not come. Something changing here. So then you solve the step by step. First step, solve here, make equation. Second step, solve and putting the value of both the step in equation first, then your correct answer. So this about solve this way and not down. Yes, student, next question I am taking here. Question number 6. This is an important question here. Same differentiate y equal to 2 function you are given. You will take log and solve it. Process is same there. Now start question here. First, y equal u plus b. Every question, suppose in this type question you are looking the n equal here. First convert in this form. Then differentiate here. Dy over dx equal differentiate du over dx plus dv over dx and make it first equation. After that, you will solve what value of the u here. You write here now u equal x plus 1 upon x whole exponent is x and v equal x exponent 1 plus 1 upon x. Then u equal, first I am taking the first step here, x plus 1 upon x and x. Taking log u equal log x plus 1 upon x whole exponent n. Then you write here x log x plus 1 upon x using the log and here, and this is the log u. Then you differentiate here, differentiate with respect to x. Now look here first. This is the given question. First write in this form u plus b given. This first term will be the u, second term will be the b, and differentiate this term here. Then you will find the du over dx in this step, and in this step you will find the du over dx, and putting your value, then your final answer. Second thing here, then you will write here what is value of u and separate way, taking u in first step and using the, suppose you are solving of the identity of the log here, then using the identity here and x log x log m upon m whole power n, then using the identity and then you differentiate here. With respect of 1 upon u, and this will be du over dx. Similarly here, the du over dx, this is the first function, and log x plus 1 upon x is second function. This first function and this is the second function. So what is the way, what formula of this? First function differentiate of the second function, and second function differentiate of the first function. So now look here, this is the first function here, same differentiate of the second function. What value of this? 1 upon log x means 1 upon x plus 1 upon x. This again differentiate here, this x plus 1 upon x, this is the 1, and look here, first d over dx log x plus 1 upon x. How differentiate here? First you will solve here 1 upon x plus 1 upon x. log x means 1 upon x. Again you will differentiate here x plus 1 upon x. Then you will write here same x square plus 1. This is the value x. And differentiate of the x is 1. Or here 1 upon x. You will write in this form x minus 1. Inverse form. Then you write here x minus 2. Then what is left here? X square plus 1. And then 1 minus 1 upon x square. This value, when you differentiate of this, then value come here. I am directly writing here first function differentiate of this x plus 1 upon x, differentiate again x is 1 and differentiate of 1 upon x minus 1 upon x square. According this way, you look this again. Suppose here this is your differentiate only single terms here. The log x plus 1 upon x. So how to differentiate here? This is the log x plus 1 upon x and this is differentiate of the x. This 1 upon x write the x inverse. The differentiate of x is 1 and differentiate of the minus inverse is minus 2. Then you write in this form. The differentiate of this term is equal to this form. I am writing here. Then plus log second term will be same here x plus 1 upon x here and differentiate of x is 1. This is the 1. Then you will write here d over dx equal u. Now solve it. X square upon x square plus 1. Solving this part, taking LCM x into x square plus 1 upon x. This x will be going numerator, x into x square, and here x square minus 1. Here I am writing x square minus 1 upon x square. This step plus log x plus 1 upon x. So this x square will be cancelled here, putting the value of u. What value of u here? X plus 1 upon x whole exponent is x. This is the x square plus x square minus 1 upon x square plus 1 plus log x plus 1 upon x. Once again, first I am using the u, second first term here, then taking log here, using the identity of the log here, log m power n, then using this differentiate here with respect of the x here. The log u means 1 upon u and du over dx. Again differentiate here first, this using a product rule. First function and this is the second function. First function differentiate of this second function. This is already differentiate here. This differentiate of the second function plus second function differentiate of the first function means 1. Then calculate and finding the value of du over dx. Du over dx. This is your equation second. Similarly, we will solve this second step here. This step. Now v equal x 1 plus 1 upon x. Taking log v equal log x 1 plus 1 upon x. Then using this identity of log here, 1 plus 1 upon x equal into log x, m into n. Differentiate of the with respect to x. This is step differentiate. What we do? 1 upon b dv over dx. Here b dv over dx again right here. First function 1 plus 1 upon x, or second function differentiate 1 upon x. First function you will write same here. Differentiate of the second function 1 upon x plus second function you write the same here log x, or differentiate of the first function 1 is 0, and similarly same d over dx 1 upon x. How to solve here? I am already solved here. This is, you can write d over dx x exponent minus 1, then minus 1 upon x की power minus 2 plus 2. You will write here minus 1 upon x की power 2 in this form. If you differentiate the 1 upon x according this way, you will write here x inverse minus 1 here, x inverse minus 1, and then differentiate of this, then I will write this one x exponent. You will get this value, then putting here. Next, then you will write here dv over dx b, calculate here x plus 1 upon x into x square plus log x, and this minus here, this minus will become here to 1 upon x square also here. So now dv over dx, what value of the b? Putting here x 1 plus 1 upon x, here taking minus, taking x square, taking common here to x plus 1 minus log x. Here LCM here like from this fraction is like from x square, then taking LCM x square, x plus 1 minus log x. So this is your equation number 3rd. From equation first, with using second and third, means I am writing the value of in equation first with using the second and third. So similarly dy over dx, what value of here? Equation second, x plus 1 upon x whole exponent x, this is x square minus 1 upon x square plus 1 plus log x plus 1 upon x, and here putting value of plus b plus b x exponent 1 plus 1 upon x, and here write x plus 1 minus log x upon x square. This is your final answer. Means these two values, equation second and equation third, putting your equation first, this is your final answer. You solve in this way without any doubt. You will find the correct answer if you solve in this way. If you change the tricks, then answer will be not correct. So now note down, understand, and to practice time to time, then you will understand this. Yes, note down.